Welcome back. Now that we know how to factor using the rule sum and difference of perfect cubes, let's not forget that you may have an expression that you may think looks like a sum or difference of perfect cubes, but it's not. So pay close attention to your vocabulary. If you look at the expression I chose for your PowerPoint, I have 8a cubed minus 64. And I know what you all are thinking. You're like, oh, that is clearly the difference of perfect cubes. And yes, it has a difference sign. 8 is a perfect cube. 64 is a perfect cube. And a cubed has an exponent that's a multiple of 3. But if you start out by doing the rule difference of perfect cubes, your expression you're writing is going to be incorrect. Because like I've said all along these modules, when we talk about factoring, the first rule of factoring is always to look for what? That's right, you need to pull out the GCF. It makes your life so much easier. So ladies and gentlemen, if I have that expression, 8a cubed minus 64, there is something in common I can divide both those terms by. And remember, I want the greatest amount. Well, the greatest amount I can divide them both by is 8. So I'm going to pull out that 8 and write it in front, and then tell me what's left. And when I divide 8a cubed by 8, I'll be left with a cubed. And if I divide negative 64 by 8, I'll be left with negative 8. So I pull out my GCF, and I put in one set of parentheses what's left. Then I look at that parentheses and see, hey, is inside the parentheses yet another rule? Sure enough, if I looked at a cubed minus 8, it's got a difference. 8 is a perfect cube, and a cubed is a perfect cube. So now I can keep going and doing the rule difference of perfect cubes. So let's go over that rule again. How do we factor a difference of perfect cubes? We put two sets of parentheses, a by times a try. First thing we do, little parentheses, big parentheses. Then we put our symbols. If that's a difference and it starts out with a negative, the signs go minus, plus, plus. So in the binomial, I have a negative sign, and in the trinomial, I have two positive signs. Now, to get the binomial, I say to myself, what did I multiply 3 times to get an a cubed? That would be a. What did I multiply 3 times to get an 8? That would be 2. So that's why in my binomial, now I have a minus 2. Once I get the binomial, I use it to make the trinomial. I square the first term, I square the last term, I multiply the terms to make the middle. Square first, square last, multiply middle. So the first term is a, and if I square it, I get a squared. The last term is 2, and if I square it, I get 4. So now my trinomial, I have a squared first, and 4 at the end, last. The middle is a times 2, which is 2a. So when I factor that difference of perfect cubes, I have my binomial a minus 2. I have my trinomial a squared plus 2a plus 4. But remember, what did we do first? We pulled out a GCF of 2. We pulled out a GCF of 8. So that means we have to put the 8 in front of those parentheses. So do not forget your GCF. So this expression completely factored would be GCF was 8, and then I have my binomial a minus 2, and my trinomial a squared plus 2a plus 4. All right, let's go to the whiteboard and try one more example.